Section 8.4, Properties of Logarithms. In this section, we're going to learn to use the properties of logarithms. With the properties of logarithms, we have basically three properties that we're going to work with: the product property, quotient property, and power property. And if you think about it, we talked about in the last section how the logarithm is the inverse of an exponential function. So logarithms and exponents are related. So it makes sense that our properties of logarithms are sort of related to our properties of exponents. Like, for example, if you look at this first product here, the product property, you'll notice that it says when I have the logarithm of a product, I can separate that product into the sum of the logarithms. Well, if you remember for exponents, when I have the product of two powers, I add the exponents together. So they're related to those properties of exponents, but we're using them with our logarithms here. Now, the properties work both directions, so you can either take a product and expand it out into the sum of the logarithms, or you can take the sum of the logarithms and combine them down into a single logarithm. So you can use these properties both ways. So then you got the quotient property, which says if you have a quotient in your logarithm, you can separate that into the difference of the two, noticing that it's the numerator minus the denominator here. And then finally, the power one. The power says that if I have an exponent within my logarithm, I can actually move that exponent to the front of my logarithm and just simply multiply it times the logarithm of my number. Now, one other note on these others, you'll notice that they have to, if you're going to be combining them, they have to have the same base in their logarithm before you can combine them into a single logarithm. Okay, so let's work out a couple of examples. Actually, first we're going to start with just naming the property that's used in a specific example, just to kind of get familiar with those properties. So let's start with this first one. It says the log base 2 of 8 minus the log base 2 of 4 equals the log base 2 of 2. So what I just look for really, like if I see subtraction in my logarithm somewhere, then I know that most likely I've used the quotient. If I see addition, I know I've used the product. If I see a number in front of the logarithm, then I know I've used the power property, or if I see any exponents within my logarithms that have been changed. Okay, so when I look at this first one, right here, you'll notice I see this subtraction right here, and I have two separate logarithms that have now been combined into one. So the subtraction makes me think that they did division. So I'm going to check that. 8 divided by 4 would be 2. So yes, on this one, I'm going to go with the quotient property that they used there. Okay, now this next one we have to kind of be careful. Let's look and see what did they actually do to this logarithm. So they started with a single logarithm that had x to the third y. And when I come over here, you'll notice that I have addition here. So, and they separated the x to the third from the y. So the addition and the fact that they separated the x to the third from the y indicates to me that they used the product. Oops. Property here. Now, you may be thinking that they use the exponent or the power property simply because there is a power in my logarithm. But if you notice from the left side to the right side, I actually didn't do anything with that power. So although I could continue this problem and use the power property, they didn't do that here. So I'm just going to stick with the product property there. Now, when I look at this last example, where I have 3 log base b of 4 minus 3 log base b of 2. Again, I notice two things. First of all, the subtraction, okay, which probably indicates division. And then I see these numbers in front of my logarithms, which tells me I'm thinking two properties were used here. The subtraction tells me that they most likely used the quotient, okay, and they also used the power. And to be honest with you, they probably used the power property first. Okay, actually they did use the power property first. They would have had to put the exponents back in here on the numbers, and then they would have used the division. So the powers would have actually gotten done first and then the quotients. Okay, so we're going to actually do that. We're going to either simplify logarithms like we're going to do on this slide here into a single logarithm, or in the next slide we're going to take a single logarithm and expand it out into the various logarithms. So first thing I want to do is check and make sure, do they have the same base so that I can actually be combining them together? And the answer there is yes. So I'm going to decide what property to use and then use it. So like log base 3 of 20 minus log base 3 of 4. I'm going to combine those together by using the quotient property, right? Subtraction tells me I'm doing a quotient. So my quotient would be to take the log base 3 of 20 divided by 4. Now 20 divided by 4 can be simplified. So we're going to do log base 3. 20 divided by 4 is 5. So as a single logarithm in simplest form, I get log base 3 of 5 instead of log base 3 of 20 minus log base 3 of 4. Okay, now my second example here, again, same basis. I have 3 log base 2 of x plus log base 2 of y. So what I want to do to this one is I see two properties. I see a power property here because of the 3 here, and the plus, the addition in the middle, tells me that it's a product that I need to do. So since this exponent does not apply to both pieces of my product, I'm going to have to do my power product property first and then do the product. So let's do the power one first. So by the power property, I would simply make that log base 2 of x cubed plus log base 2 of y. So all I did was the power property first. Now we're going to do the product. We're going to actually combine the x cubed and the y together. And to write those as a product, we're just going to get log base 2 of x cubed y, right? That's how we write that product. And then I have a single logarithm. Okay, so third example here, I see power property, I see product, and I see quotient. So again, power only applies to this first logarithm, so we're going to do that first. Then multiplication, division, we go left to right. So we're going to do product next, then we're going to do quotient. So let's do that. So first, do the power. So that becomes the log of 2 cubed minus the log of 4 plus the log of 16. Okay, so all I've done is just that power property. Now we're going to go ahead and we're going to take care of, oops, I did those backwards. Hold on, let me fix those for you. This one is the plus and this one is the minus. Okay, sorry about that. All right, so log of 2 to the third. Now I'm actually going to go ahead and do that log of 2 to the third and log of 4. We'll do the product first. That's actually the log of, I'm going to go ahead and make that 8 times 4. And I'll put that in parentheses, minus the log of 16. Okay, so now we'll do quotient. 8 times 4 actually makes 32 divided by 16. And I'll finish this up by simplifying. Log of 2 is my final answer. Okay, so that's combining them into a single logarithm. Now let's look at the opposite. So we're going to expand this logarithm instead of condensing it down into just a single logarithm. So if you look at my first example here, we have the log base 5 of x divided by y, which is obviously a quotient. So I'll need to use my quotient property here. And the quotient property tells me to subtract the two parts of my quotient, numerator minus denominator, right? It's a specific order. So we're going to do log base 5, keep the same base all the way through. My numerator is x, minus log base 5, my denominator is y. And then you check your individual logarithms that you have so far. Make sure there's no other properties that we could use to do any expanding, and there isn't. So we're finished with log base 5 of x minus log base 5 of y. Okay, now on my second example, you'll notice I have not only a product, but I have a power. So you really have to consider when there's two properties, which one needs to be done first. And in my case, my product needs to be separated before I take care of this exponent. And the reason for that is that the exponent is only applied to the r and not to the 3. So I need to separate the 3 and the r first before I can take care of this power. So my product rule is going to come into play first, and I'm going to get the log of 3 plus, right, it's a product, the log of r to the 4th. Now, like I said on the previous problem, we're going to check our individual logarithms and make sure there's no more expanding to do. And this one is fine, nothing else here, but this one I still have that power going on, so I want to take care of that. So I keep the log of 3 just the way it is, plus then to do my power rule, remember the exponent comes to the front of the logarithm and you multiply that times your logarithm. So I'm actually going to end up with 4 log r. And then I've checked my logarithms and you see there's nothing else to simplify here, there was nothing here, and I'm finished with that. All right, so for our final example, we want to look at the log base 7 of a to the 3rd, b to the 4th. And this time I have not only a product, but I have 2 powers. And kind of like the last one, since the 3rd power only applies to the a and the 4th power only applies to the b, I'm going to have to do my product rule first, then apply my power rule. So product rule first is going to say log base 7 of a to the 3rd plus log base 7 of b to the 4th. And then I check my individual logs, which show me that I still have a power to expand here. So the power property says to multiply times the logarithm, the exponent. So I end up with 3 log base 7a plus 4 log base 7b. And then when you check those logarithms, you'll notice, again, this is as far as I can expand this one, and that's as far as I can expand this one, so I am finished expanding my logarithms.